Okay, so page 8, proportions. So a proportion is a statement of equality of two ratios or rates. So for example, driving 120 kilometers per hour in 2 hours is the same as saying I can drive 60 kilometers in 1 hour. So yesterday we did unit rates, and so when we put the two together, they are called equivalent ratios or proportion. Right? And we have, so you can see 120 kilometers in 2 hours is the same as 60 kilometers per 1 hour. Okay. So setting up a proportion is one of the most important steps. Notice right here, you have kilometers on top. Then in your second fraction, you have to make sure you have kilometers on top as well. That's the key. You're going to see a lot of word problems, and the number one mistake that people do is they write it in the wrong order, and then the whole question afterwards is wrong. So if you just take 10 seconds of your time to make sure it matches up, the order is the same on both sides, it's easy. And then it becomes very easy. So in this case right here, let's say I want to solve for x, 6 kilometers in 39 minutes. Now what if I drive 10 kilometers? How many minutes is that going to take me? So I can set it up like this. Kilometers on the top, minutes on the bottom, kilometers on the top, x minutes on the bottom. So then it's just cross multiply and divide. And divide. Okay, it's just 2 steps. So 6 times x is 6x. 39 times 10 is 360. And then you would divide it by the 6. Right? So x equals, so you multiply the side with the both numbers. So when I say cross multiply, I mean like multiplying diagonally, like that. So multiply the side with the two numbers. So 39 times 10, and then you're going to divide it by the single number line. Okay? And so if you follow the step, you'll see that it will take Marcy 65 minutes to drive that 10 kilometer. So let's try example 2. So for every $10 that Sharon and Joel receive, they donate $1.75 to charity. If they receive $2,500 in total at their wedding, how much money did they donate to charity? Right? So there are a number of ways that you can do this question. I think easiest is to set up the two fractions, cross multiply, divide. I think this is the easiest way. So for every 10, so you see how you have three numbers, just like how we have it right here. We have the three numbers and the x. So set it up. For every $10 that receive, I'm gonna donate $1.75. Donate. Okay. So then for that 2,500, should I put it on the top or on the bottom? 2,500. Michelle? On the top, because that's how much I received. Good. So what goes on the bottom? Your variable. So you just put x. Okay. So I'm going to do my method. Cross multiply and divide. Cross multiply, divide. Cross multiply the side with the two numbers. So 2,500 times $1.75. And then I'm going to divide the last number, which is 10. So do that on your calculator. 2,500 times $1.75 divided by 10. That means they're gonna, it's, so what is my, if I were to write a therefore statement, what would my therefore statement be? Sen? Right, exactly. Donation. All right. Why I was asking for the final answer is because I wanted to see if you recognize you were solving for the bottom number, which is how much you are going to donate. Donation. Okay, good. Okay. Let's try example 3. Only 24% of the students remember to bring their loonie for charity. If there are 850 students in the school, how many forgot to bring in their donation? Okay. Well, this one is a little it's a little different. Okay. So this one kind of ties into what we did last week with the percentage. So if 24% remembered, how many percent forgot? Because you're trying to find out how many forgot. What percent forgot? So it's 24% of the people remembered. So 76. 76. Just like when we did the discount. So the opposite to the 100%. So 76% of the people forgot. So in this question, you're just doing 76% of 850 people. Okay. You did this last week. How do we calculate that? Sam? Perfect. Yeah. Always change that percentage to a decimal. Of means times. And so when you calculate that 0.76 times 850, you get 646. What's my unit? 646 what? Nicola? People, right? Or students. Good. Okay. I see it all the time. People say like $646. And then I'm thinking, where did the dollar sign come in from? So don't forget, it's a word problem. Read the word problem again if you need to. Okay. If you buy a stock with $100, if the next day the price dropped 10% and the day after the price go back up 10%, does that mean the price never changed? It's still at 100. What do you think? So I have a stock that at 100. One day it dropped 10%. The next day it went back 10%. Is that do I go back to 100? Who says yes? I'm back at 100. Who says no? Good job. Okay, yeah, it's not. Because, let's try. So if it drops 10%, that means it's 0. So 90% of $100. So 0.90 times 100, that means now it went down to $90. All right. And then if it went up 10%, just like when we did tax, we would do 90 times 1.10. Right? Because it's like this is 90%, this is 110%. So that's why we times it by that. And when you do that, what do you get? You get $99. So not 100. So you still lost $1. Okay. I should have wrote an extra step in here. 110% of $90. The format would have been better. Okay. Last example. The sale price of a new stove was $675 after 80% discount. What was the original price of the stove? Discussion. If you add 18% of the sale price, do you get the original price? So just like the same logic right here, you don't. Okay. So this is a common mistake that people do. they're thinking, oh, I get an 18% discount. So if I just times this by 18% back, I get the original price. No. All right. So 18% discount. So again, 18% discount means 82%. I'm paying, right? I'm paying 82% of the discount price. Okay. So that means 82% of something, and it's going to give me $675. We'll call it times the original price. Original. Okay, so the sale price of a new stove was $675 after 18% discount. So that means I'm paying 82% of the original price to get that $675. Right? So to get the original, what do I have to do in this question? We actually go back to this solving equations later on as well. So to get the original price, I'm going to do 675 divided by 0.82. Right? Since I'm timesing by 0.82 here, to get the original price, I have to do the opposite, which is divide by 0.82. Okay. And so the original price is 675 divided by 0.82. Oops, 0.82. The original price, $823.17. Okay. So that's the lesson. Nice short lesson today because it is a short class. We went over a couple of different types of examples. For homework, it's going to be page 10, 11, 12, and 13. So up to page 13. Up to page 13. Okay. Work up to page 13. All right. Just to start you guys off, write whether each proportion is true or false. Alright, so this one they're saying is 45 over 20 the same as 9 over 4. Do you think that's true or false? Alright, who says it's true? Okay, thank you. Okay, yes, you are right. It is true. Rurash. Okay, why? Why is it true?
So if you multiply 45 times 4 and you multiply 9 times 20, you get 180 both times.
Good. Okay, yeah. There's a lot of different ways you can do this. I like this this way. 45 times 4 is 180. And when you do 9 times 20, you also get 180. Okay, that's one way. What's another way? Yep. Yeah, by dividing by 5. You can divide 5 on the top and bottom, and you can get 9 over 4 as well. So that's a second way. So you see, whenever you say this equals this, no matter how you calculate it, they're still equal. Okay, so whether you're cross multiplying, whether you're dividing, whether you're multiplying, they are still equal. So yeah, this is true. Okay, So that's how you start it. And then number 4 right here, you are solving for it. So which is what we were doing earlier. 20 times 3 divided by 12. Okay. Sounds good. All right. So that's it from me. Up to page 13. Thank you.